Let's work on question 6 in this video. So we want to test the following. Under the null hypothesis, the proportions in the groups are equal versus they are not equal. The p-value corresponding to this test is going to be 0.0107, true or false. Let's see. So the intuition is similar to what we've been doing with the difference between means with the t-test, except that now we're having difference between proportions that we're going to test with the z-test. So under the z-test, we're going to have the following. We're going to have the proportion used from our samples, because remember, sample data is an estimate of population data. We're going to take the difference between p1 and p2 relative to the standard error, and the standard error in this case is going to be based on a general proportion that we're going to calculate in a second. So let's call that only p hat. 1 minus p hat multiplied with 1 over the number of observations in the first group plus 1 over the number of observations in the second group under the square root. So our task right now is to find out what's missing, and what's missing is this p hat. What is going to be our p hat? Let's just zoom out to get more space and we'll calculate. The p hat implies both groups. To find out a general proportion, a total proportion. So p hat is going to be based on the number of observations in the first group plus the number of observations in the second group relative to the total number of observations we have in the first sample plus total number of observations we have in the second sample. All these numbers are already given to us because we know them from here, x1 and x2. That's 10 and 136. So that would be 10 plus 136 relative to the number of observations in the first group, which is 88 plus the number of observations in the second group, which is 619. So plus 619, that proportion would be equal to 0.21 if we round up. So let's write 0.21 over here. Now with that in mind, we can substitute it into our data. We can substitute into our formula. I forgot to close the bracket over here. We will need 0.21. We also need 1 minus p hat, which is 1 minus 0.21, which is 0.79. Now we have everything. So let's do the math over here. What are we gonna have? Let me get some space and write it right next to it. So the z value we're gonna write over here. The differences between the proportions, that's gonna be equal to 0.114. So 0.114 minus 0.22 divided by the square root of that entire thing. So let's just take the square root of p hat. We just calculated that 0.21, so that's gonna be over here 0.21 multiplied with the remaining 0.79 times the bracket of 1 over the number of observations, which is gonna be, let me just change colors real fast. So that's gonna be 1 over the number of observations in the first sample. Recall that's 88, so that's 1 over 88 plus 1 over the number of observations in the second sample. That's 619. Everything we take in brackets, we multiply between them and we take all of it under the square root. Now if we solve the math over here, we would get a z value equal to minus 2.3. So that would be minus 2.3. Now the question is, what's the p-value that corresponds to this z-score? So let's draw it on the distribution. We'll see what z-score we're interested in. If we draw it on the distribution, z-distribution, symmetrical around the mean of 0, we found out the value of minus 2.3 that interests us. So minus 2.3 is going to be over here. That's the p-value that interests us. If we have a look at the table, that p-value corresponds to 0.0107. So it's the value they give us in the answer key. So the answer to this question is true, and we are done.